Okay, good evening once again, everyone. Welcome to class. And so today we're going to be looking at understanding the OSI and the TCP IP model of networking. This is a very crucial part of networking. Very crucial. Why do I say it's very crucial? It's crucial because it's the foundation of networking, network engineering, technical support engineer, and whatever it is that the role that you want to play. This is very crucial. Either you are going to be a software engineer, you need to understand at what layer of the network is your application running. At what layer of the network are you working as a person? So we need to understand tonight, we're going to be understanding what OSI model really means. So I'm not going to be encompassing the whole uh, module together. So we're going to treat OSI model tonight, and tomorrow, within 30 to 45 minutes as well, we're going to look at the TCP IP model. So what is OSI model? So tonight we're going to look at OSI model layers, the overview, and the functions. So when we are done with this course, we will understand what OSI model is, what TCP IP model is, and what are the comparison or the differences between the OSI model and the TCP IP model. So let's get into the class today. So the OSI, which means Open System Interconnection model, is a conceptual framework used to understand and implement networking protocol in 7 distinctive layers. Now, what are we saying? We are not saying that, oh, when I was preparing this class, I want you to understand that you are not to cram anything here. No, don't try to cram it. You are just to understand. You are just to know with time that, oh, this is the way network really works. This is how things works when it comes to networking. So the OSI model is a framework that is used to understand and implement networking protocols in 7 different layers, and each layer serves a specific function. Just like our building, the foundation serves a specific function. Without the foundation, it is impossible for us to say we are doing any roofing. It is impossible for us to say we are doing any casting. So we need to have the foundation dug. So the same thing in OSI model, there is the layer 1. Oh, we said this layer is where things are connected. So each layer serves a specific function and interacts with the layers directly above and below it. In other words, there cannot be layer 3 if there is no layer 2 and layer 1. There cannot be layer 2 except there is a layer 1. So it is impossible for them to stay in isolation or to exist in isolation. If you have a question, you can drop a chat, you can raise up your hand, and I will welcome it. So if there's anything you do not understand, as we'll explain, please do let me know. So no layer, no distinctive layer can exist on its own. So they interoperate with one another. So it is from layer 1 you can move to layer 2, from layer 2 to layer 3, from layer 3 to layer 4, on and on like that. As a matter of fact, some people's job is just between layer 1 and layer 2. For instance, microwave radio engineers, those engineers that you see that climb the MTN mast and they go and install a radio. All they do is to climb and install radio and run cable from the radio to the server room. Once they do that, and the radio is pointing to the radio at their office, they finish their own job. All they've done is run a cable. Your cable is running on layer 1. The radio is still in layer 1. And then it's connected to a switch. Oh, maybe my switch is now beginning to talk about MAC address. Okay. Or maybe it's a layer 3 switch. Now layer 2 or layer 3. So some people's job is just basically on layer 1. And they are making a living with it. So it's important for you to understand each of the layers to which a particular device is operating or functioning. Sometimes they can bring a router to you and they said, what layer does a router operate in? You should be able to say that what the layer at the end of today's class. So look at this. I saw this picture and I was so fascinated by the design. It explained everything to us. So we said there are 7 distinctive layers. We're going to be looking at them. I have them almost at every behind and before every slide, which is going to help us to understand what we want to look at tonight. So we said from layer 1 to layer 7. So from the client side, you see from the picture, from the client side, from your own perspective, as far as you are concerned, when you want to browse, all you need to do is to do what? Open your Google Chrome or Internet Explorer. That is layer 7. You type www.youtube.com and boom, you just see YouTube and you begin to browse and you begin to watch your movies. You don't know those things that happens behind that thing that you are doing. So there is a layer 6 that took place, there is a layer 5 that took place, there is a layer 4, there is a layer 3, there is a layer 2, and there is also a layer 1 that happened that made that thing successful. So let's move on. So the OSI model breaks the various aspects of a computer network into 7 distinct layers. Each successive layer envelopes the layer beneath it, hiding its details from the levels above. Now, if we are looking at it from the perspective of the server side, which is the computer side, so there is something that is happening. Layer 2 is going to hide layer 1. You won't see it. Most of us, you are browsing in your company, you don't even see cable. Especially if you are even using wireless, you don't see cable anywhere. You just see your Wi-Fi, you connect to it, and boom, you are browsing. Meanwhile, so many things are actually happening. So the 7 layers of the OSI model. So we have the physical link. Let's move on. The OSI model isn't itself a networking standard in the same sense that Ethernet and TCP/IP are. So we're going to look at TCP/IP, but when we say Ethernet, I explained something to us about network interface card, where we connect to the our laptop, and from the laptop to a patch panel or to a switch. So this is using the Ethernet protocol or the Ethernet networking standard. Meanwhile, OSI model is not actually designed as a technology, but it's a framework, it's a standard that every vendor should follow. It's a framework or a standard that every vendor should follow when they are designing their technology. Okay, so rather the OSI model is a framework into which the various networking standards can fit. The OSI model specifies what aspect of a network operation can be addressed, right, by various network standards. So in a sense, the OSI model is sort of a standard where it looks this way. Why we say standard, it's don't overemphasize this. Just understand that we have 7 layers of the OSI model. So what happens at the first layer? The first 3 layers are sometimes called the lower layer or media layer. They deal with the mechanics of how information is sent from one computer to another over a network. The first 3, that's layer 1, layer 2, and layer 3. So when we look at the the picture. So we are saying that physical layer, data link layer, and the network layer, they are the lower layer or media layer of the OSI model. They deals with the mechanics of how information is sent from one computer to another over a network. Layer 4 to 7 are sometimes called the upper layer. This one is the one we interact with most time when we are browsing. But as a network engineer, as a technical support engineer, you are going to be interacting mostly with 1, 2, 3, especially as a network engineer. And they are called the upper layer. Layer 4 to 7 are sometimes called the upper layers or host layer. They deal with how applications relate to the network through application programming interfaces. Here is a detailed explanation of each layer and its function. So we want to begin to look at each of these layers now. So we said overview of the OSI model. Now, this is it. This is some story. Don't, like I said, don't begin to go and cram. Nobody is going to actually ask you, when was the OSI layer or when was it designed? 1984. You won't go to an interview and somebody will be asking you that. They will only want to know if you have a knowledge of what OSI model really means. Oh, what layer does a router work, for instance? You say, oh, it's the network layer. Where does your fiber optics work? You say, oh, it is the physical layer, layer 1. Okay, so those are the things that are important to you. So the OSI model was developed by the International Organization for Standardization, ISO, in 1984. It provides a standard way of connecting and communicating over networks, ensuring interoperability between different networking technologies. So, what is happening here? Let me explain this. Initially, at the origin of computer networking, you can only use a HP printer with HP laptop, with HP mouse, with HP keyboard. If you bring a Dell printer to come and work with HP laptop, it won't work at the origination. But OSI model is what helps everybody to now say, okay, if you are designing your printer, for instance, and printer is supposed to operate at layer 1 or layer 2, you ensure that once you design it, every printer must be in that same layer. So OSI model brings a standard for every vendor, every technology, networking devices to operate at a particular level. So if, for instance, you said you start designing a router, your router must not be functioning at layer 2, because a router is designed to operate with IP address, and that is layer 3. So if you bring up a router today and you say your router is operating at layer 2, that means that is not a router, it means it's a switch, or you are negating the OSI model, and it will not be approved. It will not be globally recognized as a router. If you have a question, please, you can ask. So, and systems. The model is divided into 7 layers, each responsible for a different aspect of data transmission. So let's take a look at them. The 7 layers of the OSI model. Layer 1, we call it the physical layer. Very important, the physical layer. What is the purpose of the physical layer? This is the lowest layer of the OSI model. It's responsible for the physical connection between devices. It deals with the transmission and reception of raw bit stream over a physical medium, such as cable. So this is what you need to know here now. That physical layer deals with our cable. It deals with our cable. So what does it do? Transmission. What is the function of the physical layer? The first function is signal transmission. It converts the data into electrical, optical, or radio signals that can be transmitted over the chosen medium. I was giving an example the other time that, for instance, you see microwave engineers, radio engineers, they go on site, they mount the radio on the mast, and they connect a cable to the Ethernet port of that radio, bring it to their server room, and that radio is pointing to another base station. So there can be a transmission via the radio. So we call it point to point. So you begin to say, oh, is there a line of sight that the radio can begin to see the other radio there and they can begin to communicate? So we said it could be via radio signal, via optical. When we say optical now, we are talking about fiber, electrical, or any chosen medium. So the first function is signal transmission. The second function is data rate. Determines the rate at which data is transmitted, e.g., bits per seconds. So we are saying that, okay, the kind of transmission that you are you using a Cat6 cable, Ethernet cable, either Cat6, Cat5, Cat3? So what is the difference between all of these different cats? The higher the cat, the more traffic it can carry. So Cat6 will carry more data than Cat5. So another function is physical topology. Defines the layout of the network. It helps you to know, oh, is it a bus? Is it a star? Is it a ring topology? We've looked at different kinds of topology before. And hardware components, it includes cables, switches, router, network interfaces, etc. But this is what you need to understand there. That you are seeing switches and seeing routers here does not mean these devices are operating at layer 1. No. You only have cables working at this layer. That is your layer 1. Please note that. So that is the physical layer. Layer 2, which is our data link layer. The purpose, why do we need layer 2? The data link layer is responsible for node-to-node data transfer. When you hear node-to-node, you are talking about one device to another device, one PC to another PC. The data link is responsible for node-to-node data transfer and error detection slash correction that may occur in the physical layer. So it ensures that there is data transfer. So what is the function? Frame formation. Convert the raw bit stream from the physical layer into frames. So it converts it into frames, adding a header and trailer for synchronization and error detection. Okay, so we need to begin to understand something here that, okay, so in layer 2, MAC addressing is taking place. For instance, I remember, for those of us that have been in our class where we did in the last class when we were configuring VLANs, I was doing something on the packet tracer, and we're saying show MAC address table on the switch. So this tells us that in layer 2, switch is a device that operates at layer 2 of a network. So MAC addressing, it uses MAC address to ensure that data is sent to the correct device on the network. In that last class, we're explaining how through MAC address, a switch can learn all the MAC address of all the other devices connected to its interfaces. At the first time, it's going to broadcast to all the devices. But once it learns all their MAC address, the second time that there will be a packet sent on any interface to a particular device, is going to send it only to that device. So layer 2, switch is operating the layer 2 through MAC address. Error detection, another function there. It detects and corrects errors that may occur or that may have occurred during transmission. So techniques like CRC, cyclic redundancy check, are used. So just understand this as we progress in our classes, we begin to understand something. So error detection and correction also takes place at our layer 2. And flow control manages the rate of data transmission between two nodes to prevent congestion. So like I was explaining, so if we are using a hub, we said with a hub, because a hub is like is a dummy switch. When we say dummy switch, a switch that is not intelligent, it does not have a camp table where it can store the MAC address of the devices connected to it. So every time a data is transmitted, it forwards it to all the ports, which is going to cause congestion, which is going to cause um, delay on the network. So layer 2 is the data link layer, and a switch operates in this layer. Please note that. Layer 3, which is the network layer. The network layer is responsible for determining the best path for data to travel from source to destination across multiple networks. Aha. So at this part is where you see routing, where router comes into play. So here now, we are talking about IP addressing. So determines the most efficient route for data packet to travel from the source to the destination. So if you are saying, okay, I want to print, for instance, on an infrastructure, you want to print, or you want to send data, you want to send information from your system to another system, even if it is within your infrastructure, but for instance, in a different VLAN or in a different subnet, you need to have logical IP address. So at this stage, one of the functions also include logical addressing. Uses IP address to identify device on the network and to route packet between different network. So remember, we said this over and over again. The only means through which you can identify a device on a network is through IP address. You'll be able to know. Oh, and how will I be able to know? You begin to ping. You can ping using the internet protocol ping to be sure that, oh, a device is on the network. Packet forwarding moves packet from the source network to the destination network. What other functions do we have in the layer 3? Fragmentation and reassembly. So it splits up data packets that are too large to be transmitted and reassemble them at the destination. Just like, oh, when we are eating, maybe you've taken your swallow, either semo, eba, everything. So you can't take the whole big ramp of eba and swallow at once. So you cut it into pieces. However, all of them is going to settle down in the tummy at the end of the whole day. So this is the same thing that happens. So it can the layer 3 helps to break down data packets that are too large into fragments and then reassemble them at the other system where it's being sent to. So layer 3, network layer, which is where our router, our firewall, this is where they operate. And like I said, this first 3 layer is the job of technical support engineer, network support engineer, network engineer, even core network engineers. Their work is related to, you want to configure a router, you want to configure a firewall, you want to configure VPN, you want to configure IPsec VPN on any network. Your job role is within this first 3 layer. Transport layer. What's the purpose? Which is layer 4. The transport layer ensures reliable data transfer between two devices. handling error recovery, flow control, and segmentation of data. So what is the function? Segmentation. Break down large data streams into smaller segments for easier and more efficient transport. Flow control ensures that the sender does not overwhelm the receiver with too much data at once. So it ensures that things are coming at the right pace, not flooding and excessive things at the same time. So error detection and correction ensures the reliable delivery of data by transmitting lost or corrupted segments. Protocols. This is what we need to understand as well. Uses protocol like TCP, transmission control protocol, for reliable communication, and UDP, user datagram protocol, for faster but less reliable communication. Now, don't assume that because TCP is reliable, UDP is not reliable. No, both works fine depending on the kind of traffic or the kind of technology that you want to use it for. So there are some communication, or there are some transmission that does not require um, confirming if I can hear you or not. So those kind of transmission or communication can use UDP because we need it to be very fast. For instance, our VoIP section 5 or layer 5, which is the section layer. Purpose of this layer: the section layer manages sections between applications on different devices, ensuring that the communication is organized and synchronized. Section organized and synchronized. This section layer is the one that ensures that everything are well organized and they sync. So functions: section establishment, it establishes the section between the source device and the destination device. Maintenance, it maintains the section. And termination, so it manages the start, control, and end of communication section between applications. So synchronization establishes checkpoints in long data transfer, so that if a failure occur, only the data that checkpoints need to be retransmitted. So what we are saying is, if I say hello, how are you, and while you still hear hello, you have not heard how are you, something happened, it's not going to transmit hello again. He already transmitted hello to you. So the only thing that will be transmitted again is how are you. The technology or the layer that handles this is the layer 5, which is our section layer. Synchronization. Okay, we'll explain that. Dialogue control: manage the dialogue between two devices, determining who can transmit data and when. So if, for instance, PC A is sending to PC B, both cannot be sending at the same time. So when PC A is done sending, he cannot say, fine, things PC A has finished sending his own. B, take charge. B can now begin to send. So it is the layer 5 that handles this kind of communication. Layer 6, presentation layer. The presentation layer ensures that data is in a usable format and translates data between the application and the network. So when you are seeing things, it is just like it is saying presentation, it's converted to the format that you can read, that I can also read. Now, for instance, it is not this layer 6 that is going to be directly seen in our layer 1. When it's getting to layer 1, it's going to be converted to bits, the binary that we discussed before, zeros and one, because this is the language that the computer can understand. But when it's coming to layer 6, now it's going to begin to approach the level whereby Humans should be able to read it. So are you talking about PDF? Are you talking about JPEG? The way you want it to appear. So functions, we said data translation. So it converts data format to ensure that different system can interpret the data correctly, e.g. EBCD or to ASCII. So what we are saying is it's going to do the whole conversion for us. Do it for so that you will be able to understand what it has been carrying from the layer 1 all to the layer 6. Data encryption and decryption. So it ensures data security by encrypting data before it is transmitted and decrypting it upon receipt. So when you it is the layer 6 that ensures our data is encrypted when it's leaving the source and is decrypted at the destination. Data compression and decompression reduces the size of the data to be transmitted, optimizing bandwidth usage. So it ensures that we use our bandwidth appropriately. Application layer, which is the layer that every one of us always use. You bring up your phone, you have your applications, you power up the application, you do this, and everything begins to. So the application layer is the closest to the end user and directly interact with software applications that implement a communication component. It provides network services to applications. What are the functions? Number one, network services. It provides protocols that applications use to communicate over the network, such as HTTP, FTP, SMTP, and DNS. Most of us already understand how DNS works. SMTP, we're talking about our simple mail transfer protocol. So where you use for your email. FTP, your file transfer protocol. HTTP is what all of us use to browse. You open your web browser and you can browse the internet. So layer 7 is what handles all of these protocols. So resource sharing facilitates file transfer, email communication, and remote desktop access. User authentication, it manages user authentication and permissions. Data presentation, yes, this is the another part. So ensures that data is presented in a format that can be understood by the application, e.g. HTML for web browsers. So we can see it here now, from the physical layer to the data link layer to the network layer to the transport layer to the section layer to the presentation layer and to the application layer. So we're saying that it is still the same way it started from layer 1. I love this diagram because the same things now come back to red color as well at the layer 7. Nothing has been changed. We have only moved from the format that can only be understood by the computers or devices to a format that human can understand. Summary. Layer interaction. What is the summary of OSI model? Each layer serves the layer above it. So what we are saying is that layer 1 is going to serve layer 2. Layer 2 is going to serve layer 3. You see, sometimes for those of us that are in a technical environment, you hear, he said, where, you see the network engineer will check. We said, I cannot reach the interface of the router at the customer end. This is a layer 2 issue. When he says it's a layer 2 issue, that means the radio is possibly malfunctioning, or the cable connecting the radio to the switch is having issue. This is a layer 2 issue. They can go and be looking at, it's a layer 1 issue. Maybe the cable is disconnected. So you begin to hear those kind of languages. When you are hearing those terminologies, don't be scared. What they are still saying is, rather than mentioning that, oh, the cable is disconnected, they say it's a layer 1 issue. Oh, the switch is malfunctioning, they say it's a layer 2 issue. We need to reconfigure another port. You hear things like that. Oh, the port that the customer is connected to on the switch is faulty. So we've configured another port and we've connected it. And you see the network engineer will check and say, yes, now I am learning MAC address from the base station. So you see some people that are switch engineers, they work in layer 2. So each layer serves the layer above it, and it's served by the layer, and it's served by the layer below it. So what are we saying here? We are saying that layer 2 is going to serve layer 3, and layer 2 is going to be served by layer 1. So that's what that is saying there. The interaction between layers ensure that data is transmitted from one device to another across different networks accurately and efficiently. Please, the word accurately and efficiently is very important. So each layer communicating with another is to ensure that there is a distinctive transmission of data accurately and efficiently from one network node to another. So when we look at the layer interaction, encapsulation, just like we've discussed in one of the layers, as data moves down from the application layer to the physical layer, each layer adds its own header to the data, a process known as encapsulation. So the process of adding header, tail, or whatsoever to the data is what we call encapsulation. So as data also moves up the layer on the receiving end, each layer removes its own respective header, the encapsulation. So what are we saying here? So we are saying that when we type something from layer 7, for instance, and it goes to layer 6, layer 7 is going to add its own header and its own trailer and everything. Move to layer 6, to layer 5, to layer 4, to layer 3, to layer 1. That's from the client side. Once it gets to layer 1 and it's going to the server side now, from layer 1 to layer 2, layer 1 is going to remove everything that has to do with layer 1 that has been put there. Then, as it gets to layer 2 too, is going to remove the header. It's going to remove the header and the trailer that the server side has added. The same thing layer 3, the same thing layer 4, the same thing layer 5, the same thing layer 6, and then it will be presented in the format that the client understand. So that is what that is. Importance of the OSI model. Why do we need it? Standardization. This is they can ask you this question. Why do you think we need OSI model? So that every vendor can design their application, design their devices, design their network devices based on a standard. So it is the major importance of OSI model is for standardization. The OSI model provides a universal set of standards for networking, ensuring interoperability between different hardware and software. So you can now use any vendor. You can decide to be using a Crotic router with a Cisco switch, with a Avaya IP phone, with a Sophos firewall, and they will begin to work hand in hand without any issue. Then troubleshooting. So when you hear those terminologies that I was saying, oh, it's a layer 1 issue. Understanding the OSI model helps network professionals diagnose and troubleshoot networking issues by isolating problems to specific layer. Oh, it's a layer 1 issue. Once you hear it's a layer 1 issue, they are talking about cable. Oh, it's a layer 2 issue, maybe port of the switch, or maybe the switch is malfunctioning. So they configure a new switch and they take it to site. So development. The model serves as a guide for network hardware and software development, ensuring that products and technology can work together. This detailed breakdown gives a clear understanding of the OSI model and its relevance in networking. It's an essential knowledge for anyone involved or intends to get involved in networking. Thank you. Any question, please? Please, I want your questions because that is how I will know that, oh, indeed, you understand. Do we have any question?
Good evening, sir.
All right, good evening. Please ask your question.
Yes, I just want to clarify something, sir.
Please do.
As on with regards to how you explained the data link aspect.
Yeah.
So you said an example of the data link is the switch. That's the use of switches. Is that
Yes.
just to confirm? Okay. Then you now mentioned that the case of MAC address. So the reason why the systems, for example, have MAC address is so that to enable the switch communicate with them. So it's for interactions on the data link level.
Perfectly, sir.
Is
That
that
you get it. That is the primary essence of your MAC address. Every device from a vendor has a MAC address. So the switch needs the MAC address to be able to forward packet at data now. Anytime you are talking in a layer 2, you will be saying data and not packet. It is in layer 3. I think I have a picture that depicts that. Just give me some moment. So another thing you must learn from this class is what is data, or what is the thing that is transmitted, what is it called at each layer. Okay, this is it. So at layer 1, which is physical layer, it is called bits. And what are the things that are being transmitted here? It is your media, it is your signal, it is your binary transmission. Then in layer 2, it is called packets. When you, especially for those of you that are working in networking environment or support environment, when you are typing email, one of the ways to know that you are already understanding the way things work is using the right term at the right uh, OSI model. So you can say, okay, for instance, you said, oh, when you discover that it's a LAN issue, for instance, maybe the cable was reclaimed. Maybe the ROJ45 had issue. So an engineer visited that site, reclaimed the thing. So you say, oh, this is a layer 1 issue. The ROJ45 was reclaimed and the issue was resolved. Maybe it's a layer 2 issue. You say, oh, now after reconfiguring a new port on the switch, we can now see packets being transmitted on the link. Now they know that it's a layer 2 issue, but don't just say data, because it is from layer 5 to layer 7 that it is being called data. From or layer 4 rather, from layer 4. So from layer 1, 2, 3, bit, packet, and segment. So our system has MAC address. Back to your question, has MAC address for it to be able to communicate at the with the switch in layer 2. Thank you.
uh, yes, sir. Then the sorry, sir.
Okay, yeah, I'm listening.
Okay. I
I,
wanted to also say that the so from my understanding now of this, the media layers are so for example the network layers now you now mentioned that the IP address. So that the purpose is for so on in the network layer, the communication level there is between end devices. You can say it's between end devices and maybe routers.
Fantastic. Between end devices and router, you get it. Between end devices and router, that's what you need that IP for. So it's going to be saying, oh, I can reach, especially when you want to access the internet. There is no way you can access the internet with your MAC address. You need the IP address. And when your IP address is even hitting your router, especially if you are going to the internet, there is going to be need for NAT. network address translation to take place. We're going to look at all of that as we progresses. Okay, Mr. Adeyemi was raising up his hand. I could see. So can you ask your question, please? Okay, he has typed the question out. I'm going to read it out. My question. I learned, just give me a moment. I hope I can see that question. Wait, it came up. Just give me a message. Okay. Okay, so he said, I learned that data at the layer 3 network, okay? I learned data at this layer are called packets, but this illustration says otherwise. But to be very sure, it is used interchangeably, which I doubt, okay? So let's look at our design again. So majorly, what you just need to know, okay, so data link just hold on. We can just get online to check. That's easy. Um, Data at each of the layers of the OSI model. So we can easily confirm that. So he said the first layer cabling or transmission. Just give it a moment. So what is data called at each layer of the OSI model? So we should get this. This should give us a, so let's see image to that effect. So this is it. So we have bit, frame, packet. So at layer 1 is called bit. At layer 2 is called frame. At layer 3 is called packet. Yes, sometimes they use it interchangeably, but you should be able to spot the difference at one point or the other. And like I said, you don't have to cram this. You don't have to cram it. But as you begin to work, know very sure that, okay, layer 1 is bit, layer 2 is packet, or sorry, layer 2 is frame, layer 3 is packet, 4 segments, on and on like that. Any other question, please?
Yeah, thank you very much, sir, for the class.
You're welcome, sir.
Actually, I have a picture memory of things, and from what you just explained, I can picture everything. The first one is the physical layer.
Yeah,
That's something that we can see in form of cable,
fantastic.
and in cable they transmit a bit.
Yes,
So that's the Ethernet,
yes.
the first layer. So
Mhm.
with my picture memory, it means that from cable you move to a switch, which
Exactly.
is layer two.
Yeah, too.
So
Yeah.
layer two, from layer two, because of that one is a switch. From layer two, it doesn't involve internet. So
Mm-hmm.
then you move to the internet part, which is the router, which is layer, the network part,
Yes,
which is
sir.
layer three.
3. Yeah.
Yes. So from that one, you only need MAC address for router. Then when you want to connect into the external force, which is the I don't know. On layer three, we are using IP because
IP,
we have
yes.
MAC address on
You
there.
are correct.
Exactly.
Mm.
Then from that layer, we move to the transport.
Mm-hmm.
So that one we give connectivity between if we actually want to be receiving a response as we are sending it.
Yeah,
That's the TCP that you explained, I think.
exactly.
Then from that layer, we move to the session layer, the
Presentation layer,
um, presentation, and the application. I think
application. Yeah.
that's the only picture example that I have. I don't know if
Fantastic. It's good.
it's
You don't need too many. You don't complicate or try to cram. The way you've pictured it, fantastic. You go for an interview, they talk about it, you can explain. This is all you need to know. Now, when you now want to begin to configure, that is where you can now sit down and say, oh, how do I configure a Cisco router? We're going to get to all of that. And we can take things up there. So very good. Fantastic. Any other question
thank
or
you very much.
contribution,
Thank
please?
you.
Yeah, you're welcome, sir. All right. So if there's no question, thank you everyone for coming to class and do have a lovely night. We're going to complete this TCP IP model tomorrow. That shouldn't take us more than 30 minutes. So the goal is to make sure we wrap up this. So we meet tomorrow again by 8:30. Thank you everyone. Do have a wonderful night rest.
Thank you, sir.
Yeah, good
Thank
Have a
night.
you.
good night, sir.
Yeah.